Hey guys, welcome back to my channel. I have another PCM repair. This time is in a 2005 Ford Escape four-wheel drive, I think it is 3.0. Customer complaint is that he got this module from another company, Easy Repairs or Echo Repairs or something, and then they fixed the most problem on these modules is the coils drivers, and that worked out good. But he said that he didn't notice that, or he didn't knew that the actual computer controls the AC, the air conditioning to come on as far as controlling the relay to activate, and that problem was before, and they didn't, or he didn't tell them about it, and then obviously they didn't fix it. So he sent the computer for me to test it and fix it if possible, and that's what I want to share with you. I also want to share, again, I know it's repetitive, but I'm trying to, help other people around the world that they're also trying to repair computers, or the ones that are trying to learn a little bit on how do you approach a repair like this, and where you get the pinouts, and how to connect to the computer, and etc. Another questions that I got from one of my subscribers is if I'm still using the small simulator. I'm using this one most of the times, and I create my own harnesses for different computers. I also use this box in here, which I got from Wakesy. It's very handy for fast testing on computers that you don't work more like repetitive. I have created harness on computers that I work in daily basis, so I don't have to start looking for each pin every time I want to connect. Like in this case, force I do work very often, but not that often as some other modules. So just to keep that in there. The small simulator, I still have it here. As you can see, I got a harness connected to it. I got the K-Tac in there. I use the K-Tac with this laptop in here, and then I connect two different modules that I have in here for Corvettes and other old computers. I got already rigged the harness, and I use that one for those it doesn't have many different signals. With this other simulator, I can reproduce pretty much anything I need. It has for 12 injectors, 8 coils of wideband O2 sensors, and etc., that I can change the signals as I please, and it has all the values that I can read on the left side, and etc., right? So, but yes, all right, so going back to these tests, um, well, the same thing that I always do. These are the pinouts for this computer. I'm only using, in this case, the complaint is the AC. I need to have the coolant temperature sensor connected, because that's one of the inputs the computer going to use to see if it's too hot. It will never activate a compressor to not create more load on the engine, and then that's one of the reasons I have it. Communication wise, this computer has 3 connectors. Let me see. Yeah, C175, E, B, and T. E stands for engine, T for transmission, and the V for body, which is all the accessories and stuff like that. So that's what I have. Some of them I put like this one, the air temperature sensor. I put the C175B, but so if you see it says B20, that means it's connector B. If it has E, this should say like E21, which is the ECT, coolant temperature sensor, and so on, right? So those are, again, I'm just going to keep it on here. Those are the signals that I'm using, my powers and grounds. Where I get that information from, all data and Identifix. So let me actually set up the camera on the tripod, and then I will start doing the recording on the screen recording for you guys to see better. All right, put the tripod on. Things that I'm using. Let me just get the book in my hand so you guys can see. So the ACR or ACCR pin 25 on the connector B, which is the middle one. That's the ground control for the relay of the compressor, or the AC. And then we have signals, different signals. The ACPSW, that's a normally open, that comes from one of the pressure switches let me start a screen capture so we all see that. All right, I'm going to start the recording now. Okay, so let me go over to, as you can see, I put, everything kind of as much as organized I can have. All right, so this is good. So these are the signals that I need to use in order for the air conditioning to activate that relay. So I put two test lights. One I have it marked in here as an AC, that's the AC relay, and then the other one is the low fan speed, just to make sure that the computer can control that, because in this one is not much of a help from the scanner. Somehow, let's say it is, but you have to know what you're doing. Well, so we have the low fan control, which is 39, as I have it on the list. The ACCR, which is again the relay on the air conditioning. This switch, which is ACCS right here. So if we follow this line, it goes to 6. So we need to open the next PDF. So it goes to 6. So if we go this, and sorry, if we see this is a dual pressure switch. This one will be always, let me see, make sure I'm in the right one. ACCS. Sorry, AC, yeah, well, let's follow the ACCS. ACCS should have always 12 volts, and I'm going to show that. So ACCS, again, this goes to pin 6. I go to pin 6 right here and goes to the pressure switch. They show on the diagram as is always normally closed. So if this little arm right there will be on this one, it will be no connection like this one in here. That is a normally open, sorry, normally closed, and this is a normally open, just so you guys understand that. It goes to another pressure switch that says AC clutch cyclic pressure switch on right side of the engine. So it goes through here. If we follow this, it goes through the switches, the function switch on, where you move like AC, panel, floater, etc. And then it will follow these two lines. So we can have even the brown or the brown line. So let's follow the number 3. If we go to number 3, this one goes up and it's a fuse. So we know that it's supplying power through that. If it sees power on that pin, the ACCS, that will be for the computer that the pressures on the AC lines are correct. The next one is the ACPSW. That is a normally open. We're gonna see again on the number 1. I'm trying to explain the system a little bit so you guys understand. So the ACPSW is pin 26. How I know it's open, again, I follow it. So it's a black yellow. So it's pin 7 on here. I go over to the second page. So pin 7, this one will go over to the normally open switch. Again, this is a dual pressure switch. If the pressure gets too high, this will close here and it will send a ground on that wire, which will tell the computer, I got too much pressure, turn off. So that's the way that one works. So it's pretty simple as far as that. And then to see the relays, ACCR on pin 25 right here, we follow this. It goes, is the ground control of this relay, which will activate, if we follow this other line, the AC clutch, obviously on the compressor. So how I know that this side is ground side control coming from the computer is, well, obviously I follow the other leg, which is pin 1 on the relay. It's a red wire. Pin 5 goes to the second page and go to pin 5 in here, sorry, and that goes to a second relay, which is the PCM power relay. And when this relay gets activated, which is controlled just by, it's a constant ground, And this wire we will see in a second, this is only hot on the start and run. So that means if it's no power, it will not be activated. That's it. But then we have a constant power in here all the time through fuse 8 30 amps, and that will supply that power on that pin 5 that will eventually reach the relay for the AC compressor, and then the computer controls are relayed on pin 25. So those are just a little explanation so you guys can see how this is going to work. Let me put this book on the side. As far as the computer connections, you saw that on the page. Where I got that information, well, how I know which one is T, B, and E on here, I'm going to show you that. So I go over, this is all from Identifix, that's direct hit. I can see the connector C75E is the one on this side. The computer will be facing this way, and then the connector on the middle is the C75B, and then the connector on the farther end will be C175D. That's just to know which or how the connectors are. Then the next thing that I did is, well, these are the engine control colored wire diagrams, just to see a little better, you know, how they call that power ground. Those are the grounds. And then we got power on 35 and 36, which is a B power. And then there should be another one that calls battery. Yes, right here, sorry. And pin 47, that's key power of keep alive power. So it uses just 3 powers. You only, these 35 and 36 are shared internally in the computer, so you can just use one, and then the 45 as the keep alive. So you need those. And then as far as the grounds, I use 2, one on 50 and another one in 47. To know where and how to connect to, I also have the PCM pinouts, which is very handy, again, all from direct hit, which is again Identifix. It's a little blurry here, but and these connectors are backwards compared to the computer because that's the harness side, but it's easy to understand. I just use that to see which one is 1 to 11 and then 12 to 23, and then I connect the wires like that. This also gives me, just to confirm, all the positions on, you know, on the stuff. I'm going a little fast so you guys can see. You see keep alive power is B45, B power is B35 and 36, and then the voltage reference, the 5-volt reference is in B40 and E40, again E and B. The ECT is in, let me see if I find it quickly here. We got the IAC in here too. See if I find the ECT. My pass that I didn't see. Oh, it's right here. So the ECT, engine coolant temperature, is in pin E21. I have confirmed all that. I also went in and noticed that the ACCS is B15, and that is, you know, the get the book again. That is a constant 12 volts. That, you know, that's the normal application on the car. When the key on, engine off, it should be no power in there, only when the car is running. So I am doing this with the AC test. You can either put an RPM signal on the computer, or in this case we're going to go over to output this. So this is just quickly the way that I get the pinouts, and I work myself through the cars that I work in, and I get the information that I need. I also have pictures of the computer open. Again, this was worked by somebody else, and not really too clean of a work as far as silicone. It was sealed, so I can say anything in there. They did repair the coil drivers. Let me show you, and that's the reason I'm also having this. So these are the coil drivers in here. Let me just see 1 second. there is a lot of oxidation from flux left in the board that I mean, it was definitely not a clean repair. This is the EEPROM for those that might need to know. This is the main diode. This is most of the times when the battery gets connected backwards, it blows it. Um, all these I see here on the side, this one is the one that controls the air conditioner and compressor relay, and it has corrosion in there. So I think that's our problem. I already did some testing, and that's what I want you to see how I test this. So I think that's pretty much what I wanted to show. So this is just also for the records. This is the VIN number, which I already have connected the scanner and everything, but I want to start from zero so you guys see how I do it. And this one does read the VIN and does auto ID. This is a CAN network. It's a 2005, so it has CAN, and it's a faster talking computer. And this is also for my records, as you can see the way I have it connected in here. All right, so let's go over to the testing. Yeah, so let's do scanner is on. I'm now turning the computer on. I'm not sure if the camera can pick up, so let me just make sure. Yeah, that is in there, so let me just get off of the way a little bit. I'm using 13.5 volts, 1.4 amps, which is enough to what I am supplying and testing on the computer. Again, I am doing a specific repair, and that's the way computer repairs go. It's not like, oh, you are connected the entire system. It's pretty much impossible. I mean, to reproduce all the signals in a computer, and especially in the newer computer, they got communication in between other modules and so on. So I always get information to what the complaint is, and I obviously inspect the board for corrosion, like in this one, and it was left. This is solved by somebody else, so I'm going to repair what he complains and clean as much as I can see. I'm not going to remove the computer board from the case because most likely it's going to break this connector, and I don't want to do that, and I don't think it's necessary. So let's proceed with the test. So I do auto detect. I found it, so it's for USA. I don't need to save anything for this. How is that on the? You guys can see some of that. Let me just get the camera a little more angle. So hopefully it's good in there. You will be able to see the lights that are like for the AC compressor relay and the low speed fan. So we got the VIN number. Okay. It takes just a little bit to. All right, so it is an automatic transmission, 50 states, and the VIN number is the correct one. Let's just wait for the system to load. One thing I like to work on European vehicles is the communication in between the scanner and the computer is just lightning fast. Ford's actually doing really good with the new FDR system, or it's also called FCAN. It's really fast. All right, so we go to diagnosis, control unit, the PCM, again power control module, and we're going to go to active test. Again, this establishing communication going into that part of the scanner for the test that we're doing. So this light in here is for the AC compressor, and this one is for the low speed fan. They're not mixing the same one. It should be. I mean, I would really like to have controls of both, but it's not the way it is. So I'm going over first for the fan control low speed, which is not a complaint, but I just want to make sure the computer does control it. What is the scanner is asking in here if I want to have live data or just um, no live data. So I'm going to put just some things you guys can see what I'm talking about, and I get the camera close. So battery voltage, and then coolant temperature and coolant temperature voltage. All right, so so you guys can see. So we have the fan speed right now. So the fan control is off. The AC pressure switch is open, which is the way it should be. We got no air conditioning clutch requests. And that's the temperature again. And this one is very different. I'm supplying 5,260 ohms of resistors. So as you can see right now, I have 161.60. If I change that, I can change the temperature. You see it went down to 132. Right now I'm supplying 8,000, so I'm going to 5,000 to get a little bit of a normal temperature. So 160, that is correct. And then in here, I'm going to press the on. Let me just, so you guys can see how it changed, and hopefully you can see also the light on the left corner, like almost where my thumb is right now. Look at right there, and you can see now that the fan is on, even though the AC clutch is off. So this is a test. It doesn't work for me for the complaint, but at least I know the computer has full capabilities to control that fan. The next test that you need to go is output test mode, and I'm going to select the same pits, battery voltage, AC coolant temperature, and then voltage. I don't know why they put the C in there. Well, you can change the actual unit, but it's not really necessary. So I'm going to do the same thing. So now the test light for that one should be here. So I'm going to set it on, and it's on, and then off and on. And as you can see here on the right now, it says air conditioning compressor cycling switch. If I turn it off, sorry, it's right here, air conditioning clutch off, on, and it works. So that's all I'll be doing, and I will be doing as far as the scanner. I'm going to leave the scanner in here. So his complaint is only when the engine heats up that relay will stop. And so the way that I reproduce that, I use my hot air station, with, I know by experience that the ICs are located here for the AC. I'm just waiting for a little bit more temperature. See, just went off. I'm not touching anything else. It went on. See, it's definitely temperature related. See how it's right there. Right in that corner. So that's it. I mean, this is the test. I'm going now to use the microscope to show you guys. I'm going to stop the screen recording, which wasn't recording much, and I'm going to start now the microscope recording. I have a camera on the microscope that we can see that. And the problem is right where the pointer is. Hopefully you guys can see that there. I'm going to get as close as possible. I cleaned it a little bit already. I shouldn't have touched it for show you guys, but also I want to show you. You see all the flux left on this board, and that's from underneath. I ain't removing this complete board for what his repair is. These boards or these computers are not that expensive for me to spend hours and hours. I also want to change, to show Todd from North Carolina that this is his computer, and I'm going to start doing the work. But yeah, definitely the problem is right there on that corner. So let me do the repair, and that's all I want to share. So again, this is some of the process that I go through. I can turn that off. See, it's working. But so this is what I usually do. I'm going to remove that IC, clean all the pads, see if it's good. Otherwise, I got them on the stock, and I just put a new one on it. Hopefully, it's no problems on the pads underneath, and then that's it. But okay, guys. So this is what I want to share with you. Thank you so much for stopping by, and hopefully this can help others, you know, gain some knowledge on these. And it's also interesting, and for my records and for the customers, they can see that I'm doing the work. Thank you so much, and I see you next time. Bye bye.